We have more than 130 people on the show, and I'm excited to present you this monthly session of AI Talks. This is your monthly jab of highly concentrated machine learning news, 100% informative and exciting stories about the ML tools and know-hows from SoftServe. My name's Daniel, and I am happy to be your regular host for tonight's AI Talks. Recurring and a traditional saying that this talk was made possible thanks to the armed forces of Ukraine. I'm proud to say thank you for your service. Let's begin. I think we can all agree in the data science field, in the data science world, that this word called MLOps, or machine learning operations, became a buzzword for at least in the last couple years. It's not only important to extract data features and create a model that would explain all the business processes in the world. This model should be able to be seen and used by researchers and by business for getting the result, their predictions. Therefore, a set of practices have been developed for a consolidated approach that would bring about this machine learning product for ease of use by both researchers and the business. And to talk about more details and the story about the on-premise journey enhanced by MLOps, I would like to present our tonight's speaker, Kyryllo Zaitsev. Thank you so much for preparing this presentation, and I'm given the right to share share the screen with you. Please go ahead.
Thank you. Yeah, I think you should see the screen. Please. Okay. So glad to welcome you all on this talk. Today we will examine an MLOps case from our practice based on the example of Dismissal Analytics project that we did in our team. So we'll talk about a couple of things. First of all, we will try to understand why the MLOps is something that we might need for our data science pipeline. Then we will discuss the bigger picture, look at the pipeline in details. Certainly, we will dedicate some time to discuss implementation, nuts and bolts, and we will try to improve our solutions even more and actually derive some valuable lessons from what we did. So I suggest to start. My name is Kyryllo Zaitsev. I'm a software machine learning engineer, and I hope that you will enjoy the talk. So let's start. Dismissal Analytics project is an advanced AI tool that will help managers to keep their employees safe and happy doing their job in our company. So basically, it helps to predict what and why an employee might leave the company. So basically, from the manager perspective, this tool is very valuable since it helps to preserve, helps to keep financial aspects clear, helps to improve employee experience, and gain necessary insights to keep the employee happy at his place. From the DevOps perspective, this Dismissal Analytics tool is kind of challenging because the pipeline runs on highly sensitive data. It's being run on premises, and we certainly don't have much ability to scale our machines. And certainly we have security requirements since the data is employee-based and it's very sensitive. So what happens when MLOps practices are not well taken care of? what happens when the data science project has only business goal in mind. Basically, at the beginning, things simply work, and everybody is satisfied. Data scientists build cool models, and the business is simply happy that the model does its job. But there are some questions to answer. And for example, how model engineering is done, what model ran a couple of months ago, how the parameters what parameters were used, or maybe we have something additional to the pipeline. For example, its logs. For example, some data peculiarities that the model faced. Certainly, in the data science oriented project for the business with the business goal in mind, we don't have answers to this question. And well, this brings us to motivation for a new architecture to actually answer the questions and satisfy the requirements, whereby the project is enhanced with MLOps. So let's discuss a baseline solutions with which we started our MLOps journey. So basically, it was 3 non-connected machines on premises. It was the whole orchestration, the whole pipeline was a cron job plus a rendered by script, and script basically did every work you might imagine, like engineering features, like training the model, like doing inference, and everything in one script. So it's hard to manage, and it's not that easy to examine afterwards. What experiments we did, what the production model seen, and so on. So why do we need something else, something better in place of the old system? Basically, as I've already mentioned, pipeline runs are hard to examine. They have no idea, no clue what model ran a couple of months ago. And since our case means continuous evaluation of models that ran before, that are in use now, it's certainly a hard requirement that we need to honor. Then we have no easy way to control pipelines. As I've mentioned, cron job plus a rendered by script is certainly a hard way to do that. Then, yeah, how should we tackle data? How should we monitor what our model sees? Maybe there is a lot of missing data. Maybe the new data arrives, maybe something else, and we have no idea what's happening. So we need to account for that as well. Well, what we are trying to achieve is actually boosting reproducibility, transparency of our pipeline. We need to adhere to the following practices, like model retraining, like pipeline modularity, like centralized management. And by this, I mean that we need to have easy means to examine the model, examine the pipeline, tell straight away which data was in use and which model we tried to train on this data, and so on. So the environment adds certain peculiarities to our problem because we don't have a lot of networking possibilities. These are just 3 non-interconnected machines, and they are limited in their memory and computing capabilities. So basically, we can't scale our system to account for many processes at one time. And additional network usage is forbidden, so we are declining a couple of cloud-based services or whatsoever straight away. So we are on premises, we don't have connection to the internet, and we try to make our way in this rather strict environments. So how the new system might look like? Actually, we might adhere to practices by building something that has a modular structure that does all the job the ML pipeline needs to do, like processing and validating the data, training the model, and making predictions in a modular fashion. And it certainly has some means to manage the pipelines easily. So we need to, as a data scientist, we need to have some convenient UIs to examine run logs, examine model metadata, and tell in a couple of minutes what could go wrong, or just examine our system. So I suggest looking at this architecture as a potential solution. We have a set of steps the ML pipeline might contain, the one that adheres to the practices. And yes, as you can see, it's certainly not a cron job class surrounded by, it's a set of steps that are connected to each other by some orchestration entity. So we see that, okay, we have a database, we go to data, we extract the data, we transform it, process it, engineer our features, split the data, get it ready for training. Then we do our ML magic and use a model registry, something that can store and basically log what our pipeline does. It can help us identify models, and it can help us examine what exactly our experiments renders. So, this architecture basically covers our end-to-end ML pipeline. Let's take a closer look. So from the previous slide, we tried to build a general picture that we will implement later on. And now I suggest picking up specific tools that will help us to do the job. So we have several technologies involved. First of all, it's FIST. FIST is a feature store solution that helps us to do feature engineering and basically transform and version features that we use for our model, which could be very important since the data is quite verbose, and to monitor what's happening and to control it is very important. Then we have evidently as a solution for data monitoring. It can basically give us means to say exactly what went wrong with our data. So if we expected it to come in one way and our model performs poorly for some reason, it might be a data cause, and we just take a benchmark sample and compare it with the samples it derived and caused our model to perform poorly. So certainly we will discuss all these components later in the presentation when we go through the nuts and bolts of the pipeline. Then we have PREFECT as a manager, orchestration manager tool that will help us to unify all the steps, and MLflow as a artifact registry, which help us examine pipeline runs and manage models in production, in staging environments, and in an archive. So let's start diving a little deeper into the pipeline components. I suggest starting with structured orchestration, and this component helps us to run processing steps as a single pipeline. So as you have just seen, we have a couple of heterogeneous components which need to be bound together. So orchestration helps us to basically what we require from the orchestration step is to be a lightweight solution based on our requirements of the environment. If you remember, we had certain limitations regarding the virtual machines on premises. Then This orchestration solution should provide us with simple means to manage the pipelines, and the steps should be containerized to avoid packaging issues, since we are using only one machine for running the whole pipeline. So PREFECT is open source tool that satisfies the requirements mentioned, and basically with simple Python code, it allows you to create a pipeline that will be managed easily from the UI. And you might say, okay, we have Airflow, we have TensorFlow extended, and we have other tools. Why PREFECT? Well, the primary reason is because PREFECT is the most lightweight, the most simple solution to manage, and it's the most richest of the mentioned solutions, so, in terms of UI and other features. So I suggest looking at the portable table. We have PREFECT, and this tool has a decent data quality toolkit. I will help you to parse this table. It's a decent data quality toolkit. It has some access control. It has Kubernetes and kubeflow support in case we are interested in doing some Kubernetes on premises, which is certainly a requirement for most of enterprise projects. And yeah, this tool is open source, which helps a lot when you're stuck with some problem. Let's go next. Our next step is data monitoring, and here we want to basically answer the questions regarding the data that the pipeline actually that comes into the pipeline. For example, these questions might be regarding the model. Is it out of date? Because if performance decreases over time and we don't know why. Have feature distributions changed? We don't know. Maybe a feature had a distribution 1 when the model was trained, and now the distribution shifted, and now it's distribution 2, completely different from the first one. And basically, data monitoring help us to find the answers. Evidently.ai is a tool that I chose as a solution for this problem, and basically it helps us to make our data flows transparent. It allows to do comparative analysis of models. It has interactive reporting features, and it allows to plot feature target relation plots, which data scientists probably know a lot about, to tell how certain feature influences the label that we have in data. So as I've already seen, same comparison table, and probably you can ask why we choose evidently as a solution, because MLOps seems to have a lot like more green cells than evident, more pros. And the answer to it is that MLOps sadly is a cloud-based solution. So it's not that lightweight. It's not something that you would just run in your on-prem machine. And yeah, so this is the major cause why MLOps was out of our pipeline. So evidently, is your choice. If you have a tabular data, if you don't have a lot of scale, so we are not talking about millions of rows. We are talking about, for example, on the order of hundreds of thousands. This tool is working fine. Plus, it has some data stats features and which are in development right now. And so, comparative studies, interactive reporting, we have this as well in the evidently.ai case. Okay. One of the most important parts of an ML pipeline is feature management. How do we store, transform, and version features in use by our models? So basically, our idea solution will help us version control the features, will help us to minimize low-level Postgres APIs. As you remember at the beginning, we talked about some Postgres database that was heavily integrated in the Dismissal Analytics project. And for example, minimizing low-level APIs with the data could be actually of great value for our new solution. And certainly we have tabular features, so our feature store should account for this as well. So Feast is something that people use heavily on premises. It's a solution for your Kubernetes cluster. Even if you don't have one, you can set a small feast definition and basically have your feature store activated. So it's pretty lightweight. So I suggest taking a look at several pieces of Python code, which basically is our feature store solution. So it's that simple. Let's look at the top left picture, and here we just define what the data source is. So our feature store actually doesn't have materialized features. So it fetches the features from some location, which in our case is Postgres database, and Feast as a connector, which suits as well. So we just define the table and define a timestamp column that we would like to use for feature engineering in the future. Then we define, let's look at the bottom picture, we define some entities and feature views, which basically denote your features. So for example, feature view employees helps us to define a set of features that will describe an entity called employee. So basically this is it. For example, hiring date is value types. This is a string that describes a date when the employee was hired. So this is it. And then in the pipeline, we just add this 2 lines of code and receive our pandas data frame. So it's basically the most common formats for running machine learning on tabular data. And this is it. We just fetch our data from the store and make it a pandas data frame, and then use it as usual in our pipeline. Well, yes. Where are you feature stars? So basically, this title I think I added when I was completely confused because there is not much of an alternative for on-premises feature stores, and basically we have just Feast if we don't have a Kubernetes cluster in use. So as you can see, HubSpot, Resgo, and Igrazio, they are fine, but they are rather hardweight. So they are not that easy to spin off if we are not talking about some substantial compute capacity and basically on-premises environment with Kubernetes. But please notice that Feast could be used in this case as well. So it's yeah, it certainly doesn't have data quality toolkit, and it doesn't implement any access control, but yeah, it satisfies everything we might want in our pipeline. Almost our final stop is the pipeline registry. We need to answer a couple of questions like what were parameters of the model that performed a couple of months ago? What was this model? Maybe it was a random forest, maybe it was a logistic regression. And basically registry for models and for pipeline artifacts helps us in answering this problem. So we need some functionality to promote models, archive models that were in use previously, to fetch and evaluate old forecasting models and so on. So basically, a full-fledged model registry plus the artifact registry. So MLflow to the rescue. This time the choice was pretty obvious because we had already quite a lot of MLflow integration regarding the experimentation part of the pipeline. And now we will just need to add one more feature of the solution, namely its model registry. So since we have a Postgres database already set, we have everything we might need to spin off a model registry, and this would cover our pipeline artifact store in general. So we have a solution for the experiments and for models. And yeah, certainly there are some alternatives like Neptune and weights and biases, but in our case, the choice was pretty obvious since we have a Postgres database, we have already tight integration with MLflow, and we need to extend basically our pipeline with its model registry feature, and we are good to go. Finally, we have came to the CI/CD part of the pipeline. Here, we want to simplify the development process as much as possible. So we need to account for the following. First of all, our programmatic access to VMs is unfeasible from the automated CI/CD pipeline. So we can't implement something like continuous delivery. Our solution should be simple in use and support, since we are talking about a team of data scientists, not DevOps engineers. And our code is hosted on Azure DevOps platform, which adds certain restrictions to the tools we might want to use. So, and these tools are basically Jenkins and Azure pipelines. Well, since we are on Azure DevOps, Azure pipelines seems like a pretty good fit, not only thanks to the platform, but it's easier than other solutions as well, because it's only a YAML file, and it's pretty easy to use, and it has a lot of extensions like interactive reports on basically everything client might need for a CI part of the pipeline. So if all these tools solve our problem, we might ask ourselves, maybe we could do a better job by finding something more unified, something that will something that would have a solution for our problems, something that would be easier to manage, not a lot of technology, as we have just seen with FEAST, with MLflow, with PREFECT, and so on. A solution exists. It might exist, and it's called TensorFlow Extended. And basically, this solution has components for workflow orchestration, our PREFECT artifact and model registry, our MLflow feature engineering, our FEAST, and data monitoring, our evidently.ai in our case. But sadly, this TensorFlow Extended leaves almost nothing of the solution that was deployed. And you need to certainly reserve a couple of months to re-engineer everything you had, and use TensorFlow Extended in place. Plus, yes, a small side effect that it requires a lot of hacking if your models are not in TensorFlow, because for TensorFlow it has a lot of convenient suite integrations. And the FX is probably not your choice if you are talking about on-premises without some Kubernetes support, because the FX is rather heavyweight, and Apache Beam, if there are data engineers among us is to make these effects shine on premises. So basically, it has to do with big data and our solutions. Our solution needs to account just for a couple of hundreds of thousands of rows. So some takeaways from working on this problem. First of all, yeah, sadly, there is no single solution for all on-prem problems if you don't have Kubernetes. Because yes, with Kubernetes, you could discuss the whole matter a bit differently. And if you remember these comparison tables, yes, there is a Kubernetes support rule, and you need to reevaluate the choices if you have Kubernetes in place. Then many tools, yeah, provide their features, but they evolve quite rapidly, and the features which were promised at the beginning, they actually changed, and the functionality may not be available anymore, as was the case with FEAST. So its feature engineering system evolved quite a bit, and we had plenty of headache with modifying the solution to match our case. Then, yeah, certainly with a plethora of solutions of technologies that we used to group them could be challenging. And please consider a containerized approach to mitigate this. So you may face package version conflicts. You might face actually anything you might imagine on the on-premises environment. So, and please account for that as well. So in summary, we built a new architecture that makes the pipeline modular and that basically split cron job plus random into a set of modularized components that each of which solves the task, and basically it holds some MLOps best practices, namely orchestration, feature store, model registry, artifact registry, and so on. So the pipeline actually became something that is easier to manage from the UI, that is easier to examine, and the insights from which is easier to fetch in the future. So as a summary, on-premises environments, especially on non-enterprise scale, put significant constraints on what you might and might not use as potential solutions for your MLOps problems. So to tackle the design task in these cases, one is to balance gracefully scale, security, networking, and ease of use of the ML pipeline. Because as you remember, we had TensorFlow extended, we have Feast, which data scientists might not be happy about, but it's actually introduces some manageability of the pipeline. And for example, we declined a couple of solutions due to the networking issue, and certainly we need to include security in all of the evaluations that we do for our tooling in use. So security is a paramount concern. So yeah, certainly we had something in mind when we ended our work on the pipeline, and one may actually simplify analysis of pipeline logs by introducing some additional UI tool. One may use a security manager within the credentials and connection keys, for example, to boost security even more. One may create some more interaction for comparative studies or for custom models, since in our case, we have plenty of models that need to be examined and actually compared with each other. And interface to do it easily might help. So yeah, and there are certainly features in the Azure pipelines as well that we didn't use, like alerting and reports that might boost code quality and actually manageability of the pipeline as well. So I put quite a bit of useful links for you to examine, and yeah, these links point to, for example, data monitoring component solutions. So how my choices were made, how actually other tools compare. For example, this is a great report on the Great Expectation tool by my colleague, MLOps engineer, and you should definitely check this out to give yeah, a bigger view on the monitoring components and features those in orchestration as well. So please make the MLOps be with you and make your pipeline follow MLOps best practices. Thank you very much for your attention.